Okay, as soon as we finish this, we're gonna start making corrections or expansions. This one is probably more of an expansion than correction. That is, when I did the conservation of momentum, I just said the momentum conserve always, but that's probably a overbroad statement. What really happened is that you have a object and then another object. They do some kind of interaction. They collide or whatever. They influence each other. After this collision is over, first they come in, and then after the collision over, let's just say, for example, then they go out. We say this is M1, this is M2, this is V1 initial, V2 initial, this is V1 afterwards, T at the time T, this is V2 at the time T. Of course, these are all vectors, and yeah, we say that M1 V10 plus M2 V20. This is initial momentum. We define momentum as an object at that velocity. Of course, momentum is a vector as well. This equals to M2 V2t. This is at the end of the after the collision, or well, actually more than that. But anyway, we'll get to that later. Oh, okay, I write it the other way around. 1 V1t. Okay. We understand the conservation of energy is basically energy. We can understand when there is a process that releases energy. For instance, when two balls run, after they run this, they're together, and there will be loss of energy, because if they're elastic, that may not be. Actually, if you go this way, you can calculate if energy conservables, how it's going to happen. It's not going to get stuck together. It'll bounce, because as a spring, elasticity, when you look at it, it's like a spring. When you look at the spring, when something hit it, it's not going to get stuck. So this is going to move down and then bounce back. It'll push the other thing away. Okay, now the supplement here is at what time this equation holds. We say in the video, we say it holds always. Now we're gonna explain when this is good. Newton's third law says if two bodies act on each other, the force that M1 put on M2 is equal to the force that M2 put on M1, just the other direction. Let's just call that call this F1, call this F2. F1, this force has a direction, of course. Then there's F2, that force has a direction. Newton's third law says this is the other direction. Now, we're gonna how do you do this? Okay, we can do it this way. For instance, we can do we know F equals to M dV dt. We put this in here, which is M1 dV dt. This will be the V1, obviously, and put this in here, it will be minus M2 dV2 dt. We're going to take the dt out, that then becomes M1 dV1 equals to minus M2 dV2. Of course, here M1 is we're assuming the mass is not changing before and after. So M is going to be always that mass. So what we're having is we take an integral of it, that becomes mv1 from 0 to t equals to m minus m2 v2 0 to t, because we're going to integrate both sides from 0 to t. We can write it here from 0 to t, right? From 0 to t, right? Actually, from v0 to let's see, from 0 it's a derivatives on time, okay, which is from 0 to t, okay. So this becomes the time 0 to the time t. This is time 0 to time t, and then all we need to do is, this is the magic about integral. We know that here is a derivative of v1, so when you integral, it becomes v1. That's all magic about integrals. Now it's m vt 1t minus m1, obviously here, v10, right, equals to minus m2 v2t minus v20. Okay, we clean this up, it becomes this. You move this, you rearrange this, it'll become this. Okay, this is in other words, the conservation of momentum is exactly another way to say Newton's third law. In other words, two objects react and there will be a force in the opposite direction. This, in other words, this is exactly a restatement of this. That's it. This is this part. Throughout this this lecture series, we want to make everything. We derive everything. Nothing is given for sort of jammed down anybody's throat. We explain it. If we find out anything else that's not part of the system, or we haven't explained, we'll explain it. The reason for such a lack of explanation is we're rushing for schedule. There are schedule conflicts, so we cannot extend that lecture anymore. And so the last day we were rushing, so we didn't do this part. So we make it up here. Okay, that's it. Bye-bye.